Pascal's law application, the first application is hydraulic lift. In a hydraulic lift, the fluid is, say, oil. Purpose of this arrangement is to multiply force. You apply force F on one side and you get more force on the other side, capital F. For example, if you have to lift a car, suppose you need 10 persons. Without this machine, you need 10 persons to lift a car. But using this machine, one person is sufficient to lift the car. How? This force will be 10 times this small force. How it is possible? You apply force, small force on left side and this piston moves downwards. If this piston moves downward, it will press the fluid downwards, oil downward. Because of the same pressure, this oil will press it upwards and this piston will move upward. So, if you say P is same, that means what? F by small a, pressure on this side, applied force is F, area of the piston is A, pressure is force divided by area. So pressure on left side is what? Small f by small a. On right side, force is capital F, area is capital A, pressure is F by capital A. So this force F is how many times small f? If this area is 10 times, capital A is 10 times small a. If this piston area is 10 times this small piston area, then capital A by small a is how much? 10. So this machine is a force multiplier. The force applied was small f, force on the other side was capital F. It was how many times? 10 times. So if there are 10 persons required to lift a car, using this machine, one person is sufficient to lift this car. This is one. Second aspect of the same is it is not a work multiplier. It is not a work multiplier. Why? If distance covered on this side is D, distance covered on the other side will come out to be what? Volume of oil remains same. Area into D, then the second piston will move upward, not by D, but by D by 10, because the volume covered remains same. Volume on this side is A into D, volume on this side is 10A into D by 10, 10 cancel, again volume is A into D. So, what is work done on left side? Force into distance. Work done on right side, that is right piston, is a capital F, force into distance. Distance is how much? D by 10. This capital F is how much? 10 times small f. It is D by 10. This 10 is cancelled. What you get is F into D. That means work on left is equal to work on right. This machine is a force multiplier, but it's not a work multiplier. Now we will have a numerical on this machine. Using the numerical, we will have understanding of the same. Numerical is page number 7 by 86. Numerical is the neck and bottom of a bottle are 2 centimeter and 20 centimeter in diameter respectively. If the cork is pressed with a force 1.2 kilogram force in the neck of the bottle, calculate the force exerted on the bottom of the bottle. Yes, given is what? Diameter. Yes, capital A by small a is equal to pi dia, large size, square, by 4. Pi by 4, this is dia, large size, dia, small size. Area is how many times? Dia is what? Value of dia is what? Large is 20 centimeter, small is 2 centimeter, is equal to 10 square is what? 100. Area is how many times? 100 times. You have to find out what? Capital F or small f? Capital F. You have to find out capital F. Capital F is equal to A by A. This is area, large area is how many times small area into F. Large area is 100 times F. What is value of small f given? Small f is given 1.2 kilogram weight. So 100 into 1.2 kilogram weight comes out to be what? 120 kilogram weight. The concept is same. Whether you make the diagram in this form or this, it is same. This area is how many times this area? 100 times. So area multiplier is 100. So force is how many times? 100 times. 1 minute to complete. Third application. Yes. Application number 3 is what? Hydraulic brakes. Application number 3 is hydraulic brakes. How brakes function in a car, in a vehicle. This is where the driver will apply the force, foot operated brake. Driver will apply force here, and what you have is liquid brake oil. This brake oil is applied to all the wheels. If there are 4 wheels, then there is one pipe which leads to each wheel. We will discuss only one wheel. So there is a liquid inside. Here you have a arrangement piston. So what you have is oil here. Where is the wheel? These are 2 brake leathers, brake shoes, and suppose this is the wheel. Red color is wheel. When the driver will apply the force, it will create what? High pressure in oil. This pressure is transmitted to all points as per Pascal's law. This is transmitted to piston number P1 and piston P2. When it is transmitted to piston P1, it will press it, this brake leather will move outward, will press what? Wheel. This will also move outward. It will press the wheel. So as this touches the wheel, there is a friction, and because of friction, there is opposition, and the wheel stops. This is how the brakes are applied. Now, the issue is these two brake shoes should come back. That is why you have a small value spring, so that once the brakes are applied, after that it comes back to original position. When the driver will lift the foot, pressure is released. These should not touch the wheel then. They should come back to its original position. So this spring will do what? Will restore the brake shoes to its original position. This is how. This is for wheel number 1. If there is another wheel, wheel number 2, same pressure is applied on wheel number 2 also, 3 and 4. So that means what? All the 4 wheels will experience equal braking. Advantage, the braking is very smooth. All the wheels experience equal braking. Braking is very effective. If it is unequal braking, then the vehicle skids on the road. If it is unequal braking. Time with you is 3 minutes.